Uh, Welcome everyone. Today we are launching uh, the second part or unit uh, by dividing into chapter 4 Introduction to Health Informatics. We are moving from general computer fundamentals to dedicated domain of health informatics. This session will cover how biomedical data is transferred into clinical wisdom and how various sub-specialty interact to support patient care. Uh, Objective our roadmap for this chapter before exploring core concepts. By the end of this lecture, you should understand how to evaluate information architectures in clinical setting. We aim to move past technical definition to understand how these tools solve practical real-world clinical problems. Introduction to Health Informatics. Uh, Health environments generate massive volume of data daily. Uh, it focuses on collecting, storing, processing, retrieving, analyzing, and sharing health information to support healthcare professionals, uh, making informed clinical and administrative decisions. So managing this data efficiency is critical for patient safety and quality care. This chapter introduces intersection of healthcare information technology and the data science. Health informatics is an interdisciplinary field that combine healthcare information technology, computer science, and data science to improve the quality, safety, efficiency, and accessibility of healthcare. So modern healthcare generates enormous amount of information every day, including patient medical record, laboratory report, radiology image, medication prescription, public health report, insurance information. So without effective information management, patient information may be lost, medical errors increase, communication become difficult, healthcare costs increase. Health informatics helps solve this problem by organizing and managing health information efficiently. So what's health informatics? The core definition of as interdisciplinary field studying. It is often misunderstood as just computer is no hospital, but it is much broader. It is an interdisciplinary trade without the health science. It has no clinical directions without engineering. It lacks technical engine. Most important, without cognitive science, we fail to understand how human clinicians interpret information on the screen, which can lead to medical errors. So, strategic effort to improve the human health inquiry and clinical decisions, especially the three distinct disciplines: health science, computer engineering, and the cognitive science. Health science is a medicine, nursing, pharmacy, public health. Computer engineering, hardware, network protocol. Cognitive science, human-computer interactions, information science, or decision theories and linguistics. American Modern Information Association as the science of how to use data, information, and technology to improve human health and healthy delivery. WHO, health informatics refers to the systematic application information and communication technology to support healthcare service, public health, research, and health management. So the data transformation or the pipelines information is generated. Here we have for data, especially how does a raw number on a patient chart turn into life-saving medical decisions. This is explained by the data, information, knowledge, and wisdom. For instance, computer excel at collecting data and organizing into information. Modern informatic tools attempt to assist with knowledge by crossing reference information with clinical guidelines. However, wisdom remains specially uniquely human trained. It requires ethical judgment and clinical experience to apply knowledge safely to an individual patients. So information is a processed, structured, uh, contextualized to add meaning, like identifying one photo indicates a hypertension or for specific patient. Knowledge is synthesized, interpreted information, integrated with clinical experience. Knowing the clinical guideline to treat hypertension. Wisdom, the critical application of knowledge to specific patient scenario. Choosing the safest medication based on patient's unique medical history. So, historic timeline is the historical evolution of the field or health informatics has evolved over several decades alongside advances in computer hardware. The formalization of health informatics began in the mid-20th century as digital computer moved into corporate and academic institutions. In the 1950s, early experimental and computerized medical logic Robert Lilly and Lewis published pioneering work analyzing medical diagnosis logic using symbolic reasoning. The industry recognized that standard business programming language couldn't handle complex text-heavy and clinical narratives. This led to specialized database tools, especially in 1916, the birth of early specialized informatic bodies such as organizations that would become the International Medical Informatics Association, development of Massachusetts General Hospital utility multi-programming systems, programming language and database system built specifically for clinical data. In 1970s, emergence of early hospital information system, clinical decision support prototypes such as MySyn, rule-based system for identifying bacterial infections, especially expert system, provides that computer could assist with antibiotic selection. So in 1980s, the microcomputer allowed system to move out of centralized computer room and directly onto laboratory desk and the nursing sessions. And 19th, the explosion of internet and web browser shifted the focus toward distributed health system network connectivity and the early web-based patient registry. From 2000, government mandate globally such as National Health Digitalization Strategy drove widespread adoption of enterprise electronic health record, mobile health applications, advanced artificial intelligence diagnostic, where we are in the era of enterprise electronic health record scaling and artificial intelligence analytic moving toward highly integrated national infrastructures. So the evolution from paper record domination healthcare limited computer use to hospital began using the computer for billing, patient registration, administrative tasks. Then development of hospital information system, laboratory information system. Then growth of electronic medical record, clinical decision support, and the rapid expansion of electronic health records, internet-based health service, telemedicine, and today health informatics include artificial intelligence, machine learning, big data analytics, mobile health, wearable device, internet of medical things, precision medicines. So the subspecialized of healthy informatics are uh, operate across multiple scale from microscope DNA standard to entire population. The discipline divided into sub specialties. So health informatics broad discipline with sub specialty organized around the target user or level of biological organizations. Bioinformatics focus on cellular, molecular, and genomic data processing for precision medicines, like handle molecular and gene level data, which is essential for target drug development. Clinical informatics optimize patient care delivery directly at the bedside. Subfield medical informatics and nursing informatics are for frontline providers. Immediate workflow of doctors and nurses inside the hospital. Consumer health informatics focus on patient face tools, personal health records, and mobile applications. Uh, this empowers the patients themselves outside the clinic. Public health informatics focus on population level disease surveillance, outbreak tracking, and epidemiology. This operates at the macro level, tracking wide-scale population outbreaks, vaccination metrics. The structured triangles or the three interconnected core pillars. When deploying an informatics platform, it helps to visualize the initiative through these three foundation pillars: people, process, and technology. Many healthcare institutions fall into the trap of thinking that buying expensive software technology will automatically fix their clinical issue. If you don't adjust your administrative workflow process or train your clinical staff effectively, the new system will fail. All three pillars must be developed in tandem. So, informatics insights succeed or fail based on these three interconnected points: people, clinicians, patient, technical person. Process is a workflow, structure, data entries, or institutional guideline, technology, hardware, infrastructure, softwares. Technology alone cannot fix broken process or uncooperative pupils. So the institutional drivers or the importance and the strategic value. Hence, informatics provide numerous benefits for patient, better quality of care. Uh, Patient safety, reduce adverse drug events via automated allergy flag and interaction alert. Clinical efficiency, eliminating redundant laboratory radiology tests via cross-department sharing. Evidence-based care, embedding proven clinical guidelines directly within the provider workflow. Financial optimization, this streamlining medical coding, lowering billing error rates. So this for patient better quality of care, improved safety, fast diagnostic, reduce waiting time, better continuous for health professionals, easy access to patient record, improved clinical decision, better communication, reduce paperwork, increase productivity, even for the organization, better resource management, low operational cost, improve reporting, better planning, and improve quality assurances. The human capital role, and here who coordinates this complex interaction. The specialized role within the health informatics. Software engineers do not typically understand healthcare delivery, and the busy doctors don't write database code. So the translator is one, the bridging the gap between software engineers and the clinical persons. Uh, Chief medical or chief nursing information officers, uh, especially this role ranges from executing strategy to tactical configuration specialists along with analysis who harvest data to prove whether clinical outcomes are actually improving. Information specialists is workflow analysis who configure software to match the operation reality of staff. Clinical data analysis specialists extracting the visualization complex array to support quality audit. Educators train ensuring frontline competency and platform safety compliance. The system implementations or the core applications like electronic health record, centralized digital profile mapping patient long-term medical history, or digital chart containing a patient comprehensive medical history, like computerized provider ordering tree, digital diagnostic drug ordering to replace handwritten script or provide or system allowing doctors to input medication and lab order digital to reduce errors. Clinical decision support is active logic engine provide real-time diagnostic alert and dosing check that alerts and reminders built into a software to assist with clinical dosing and diagnosis. Telehealth framework system enabling remote clinical consultation and real-time biometric tracking, remote delivery of clinical service via video consultation and remote monitoring. The real-world barriers or structures challenges, interoperability. This is especially the system challenge getting the separate software system to read and parse each other data smoothly. So about integration, having poor internet connectivity, power interruption, hardware failure, software problem, maybe data security, or this is especially the privacy, confidentiality, integrity, accessibility, safeguarding highly sensitive electronic record from ransomware and the database breach. User burnouts, resistant to change, or complex interface and heavy data entry burden can lead to clinical charting fatigue, limited computer skill, also inadequate training, high capital cost, substantial upfront expense for software procurement, hardware updates and maintenance, highly implementation cost, maintenance, hence software licensing, and so these are most challenges, especially in Ethiopian context. Ethiopia Health Information supports the digital transformation of healthcare systems through electronic medical record system in hospital, district health information softwares for routine health reporting. This is a free open source web platform used by Ministry of Health over 80 countries for routine health data collection, disease surveillance, and health program management. Electronic community health information system used by health extension workers, like on mobile tablet platforms that digitize paper-based family orders and data collection tool for health extension workers. Key components: integrated health program module, automated client tracking and reporting, digitalized referral link to health centers, telemedicine initiatives in selected health facility, national digital health strategy led by the Ministry of Health. Health informatics is the integration of healthcare informations, technology, and data management to improve healthcare delivery, enables efficient collection, storage, analysis, and sharing of health, supporting better clinical decision, enhance patient safety, improve healthcare quality, and a stronger public health system. As digital technology continue to evolve, health informatics has become an essential component of modern healthcare worldwide, including. Here we have review and discussions. This review questions apply this concept to real-world clinical logic. لمثالي, the first question is try using lab value like fasting blood glucose reading or patient body temperatures to map the data information knowledge and wisdom. The second question, especially think back to our structures training slide. How can excellent software fail if the clinical workflow is not updated? Last, imagine an unconscious patient transferred without their medical history. How does a system communication failure create clinical risky? Who wants to start? So this is all the first part of foundation of health informatics. Next, we will see health information and healthcare systems.